we need to differentiate each of these functions. So firstly, y equals 3x to the power 4 times e to the power 2x plus 3. So this is the product of two functions. We've got the 3x to the power 4, and then we've got the e to the power 2x plus 3. So we're going to use the product rule. I have put a quick reminder of the product rule up here. So I'm going to say that my u function is 3x to the power 4, and I'm going to say that my v function is e to the power 2x plus 3. So differentiating my u function, differentiating this 3x to the power 4, I'll get 12x to the power 3. Now differentiating my exponential function. Well, notice in this case we have got the 2x to the power 3, 2x plus 3 inside the exponential function. So therefore we're going to have to use the chain rule. So we're going to differentiate the outside function first, which is the exponential, and that differentiates to be the exponential. And then by the chain rule, I have to multiply this by the derivative of the inside, and when I differentiate 2x plus 3, I get 2. Right, let's now apply the product rule then. So dy by dx is equal to u dash times v plus v dash times u. So u dash times v plus v dash times u. And just simplifying that a little bit. And then the 2 times the 3x to the power 4 is going to be 6x to the power 4. And we could leave our answer like that. Or we could do a little bit of factorizing here because we've got several things that are in both terms. We've got the e to the power 2x plus 3 that's in both of these terms here. We've got an x cubed that's in both of these terms. And then we've also got a 6 that's in both of these terms. So let's factorize the 6x cubed e to the 2x plus 3 outside. And on the inside, we'll be left with 2 plus x. And that's how I would leave my answer. Next, we are differentiating y equals x times the square root of x minus 1. So I'm going to say that the x is my u function, and I'm going to say the square root of x minus 1 is my v function. So u equals x, v equals the square root of x minus 1, which, considering I'm going to be differentiating it, I'm going to write that as x minus 1 to the power of 1/2. Differentiating the x, I'll get just 1. Differentiating the x minus 1 to the power of 1/2, I will get 1/2 times x minus 1 to the power of minus 1/2. And that's it. Right, applying the product rule then, I've got u dash times v plus v dash times u. So we'll have 1 times the x minus 1 to the power of 1/2 plus x times 1/2 x minus 1 to the power of minus 1/2. And again, we can do a little bit of simplification here. First of all, 1/2 times the x is just 1/2, or x over 2. Then I am going to rewrite this x to the power of minus 1/2. I'm going to rewrite that on the denominator. And then what I'm going to do is I'm going to get a common denominator, just to write this as simple as I can. So the first fraction here, I'm going to multiply top and bottom by 2x minus 1 to the power of a half, so that it matches up with the denominator here. So if I times the numerator by that, I've got a 2, and then the x minus 1 to the power of a half times the x minus 1 to the power of a half, that I'm timesing by, will just be x minus 1. Because the powers of 1/2 add together to give me a power 1. I've now got a common denominator, so I can add these two things together to be a single fraction. I can expand those brackets to get 2x minus 2, plus the x is going to be 3x minus 2. And that is how I'm going to leave my answer. Part D. Again, product rule, because we've got x squared, that's my u function, and then we've got ln x plus 6, that's my v function. So u is x squared, v is ln x plus 6. Differentiating the x squared, I get 2x. Differentiating the logarithm, I get 1 over x plus 6. Applying the product rule, so u dash times v plus v dash times u. So we'll get 2x times ln of x plus 6 plus x squared times 1 over x plus 6. And that is probably as simple as I can write that answer. So I think I'm going to leave my answer like that.